Back to our problem solving. This is from an extra worksheet that's available to you. I'll do this one here to get your minds back into it. We have a load of bricks hanging by two cables at 30-degree angles. The load of bricks, or whatever the object is, has a weight of 25 newtons. So here's the diagram I've drawn to go along with the diagram given. You see the 30-degree angles for the cables, and I assume that the cables will have the same tension. In fact, they would, supporting that load with equal angles like that. The basic steps for these problems is to draw a force diagram, calculate the components of forces that are at angles to the XY coordinate axes, and then to construct net force equations from which we can calculate unknowns. And here's the force diagram for this situation. Since both angles are 30 degrees, the tension forces will be the same, so I just use T. And I do not rotate the XY axis because there's no way to line up more than one of those forces on the XY axis. So I just leave it as is. The next step is calculate components, and those are 30-degree angles. And here's Ty and Tx, and the same thing over here, Ty and Tx. Equal tension forces will have equal components. And the last step is to make the net force equations and hopefully see a way to calculate the unknown tension force. And for clarity, I have made this tension 1 and tension 2, even though they'll be the same. I do have different sign components, T1y, T1x, T2x, T2y there. So the sum of the force equations for horizontal, it's going to be T1x plus T2x, and since the object is at rest, that's going to equal 0. Those two forces must be equal in magnitude to each other. For the vertical direction, the sum of the forces in y are the two y components plus the 25 Newton force that's down, so it's negative. Thinking about this and putting in what I know the sum of the forces must equal 0 vertically because it's not moving. Forces are balanced, and T1y and T2y, I know those are the same because the tensions are the same. So I'm going to call that T2 times Ty, and there's a minus 25. So that means plus 25 newtons equals 2 Ty. Therefore, Ty must equal 25 divided by 2, or 12.5 newtons. So that's the value of the vertical component for each of those tension forces. Now I can figure out the actual tension forces. The sine of 30 degrees right there is going to be Ty divided by the hypotenuse, which is T. Do the algebra, that means T equals Ty divided by the sine of 30. And do the math, and it turns out that the tension in each cable is 25 newtons. So the tension is 25 newtons. The problem also asks to do this if the angle was 5 degrees, and I'll leave that to you to figure out.